Hey welders, welcome back to the channel. Today we are diving deep into one of the most essential yet confusing specs on your welding machine, the duty cycle. What it means, why it matters, and how to calculate it so you never overheat your machine again. Let's start with a definition. The duty cycle tells you how long a welding machine can run continuously before needing to cool down, typically over a 10-minute period. That means if your machine has a 60% duty cycle, you can weld for 6 minutes, and then it needs 4 minutes to cool. Example, 60% at 200 a weld 6 min, rest 4 min. 30% at 250 a weld 3 minute, rest 7 minute. When you weld, your machine heats up. Internal parts like transformers, capacitors, and transistors generate heat. The duty cycle prevents overheating and damage. If you exceed it, your machine will shut off or even deteriorate faster. This protective shutdown is often done by thermal overload protection, a safety feature built into quality welders. How is duty cycle actually calculated? It's simple math. Formula: duty cycle, in percentage, equals welding time divided by total time, multiply by 100. So if you weld 6 minutes in a 10-minute period, 6 divided by 10, multiply by 100 equals 60%. Important. Duty cycle is usually rated at specific amperage and temperature. Run the machine at higher amps and the duty cycle typically drops. Manufacturers test duty cycle under standards like EN 60974-1, a tough 10-minute test that helps ensure real-world accuracy. Not all brands use the same test, so always check whether the rating follows recognized standards. Tip: beware of machines that advertise high duty cycles without transparent testing standards. Numbers can be misleading. Duty cycle is not a fixed value, it changes based on how you use your welding machine. The biggest factor is amperage. Higher welding current produces more heat inside the machine, which reduces the available duty cycle. Lower amperage means less heat buildup and longer welding time. Ambient temperature also matters. In a hot workshop, the machine cannot cool itself efficiently, so the duty cycle drops compared to working in a cooler environment. The cooling system plays a huge role as well. Machines with powerful fans and good airflow can remove heat faster, allowing longer continuous welding. Finally, machine condition is often overlooked. Dust, blocked vents, and worn components cause faster overheating, which shortens the duty cycle. Regular cleaning and maintenance help maintain proper performance. So remember, duty cycle depends not just on the machine rating, but also on how and where you use it. To wrap up, duty cycle is one of the most important specs on your welding machine. Understand it, respect it, and you'll get better welds and a longer lasting machine. Let me know in the comments what duty cycle your welder has. Like, subscribe, and hit the bell icon for more welding tech tips.